Okay, in this video we're going to talk about the volume and calculating the volume in some basic shapes. When we talk about volume, we're talking about measuring a three-dimensional area. In other words, how much liquid would something hold? Volume is usually measured in some kind of squared units. Okay, so this would, instead of being, or not squared units, they'd be cubic units. So unlike area, which is a square unit, volume is a cubic unit. So it would be like inches cubed or feet cubed. We also have some special units that let us kind of get away from using some kind of unit cubed. We can use units like the gallon, which is already a cubic unit. And it has a conversion if you want to convert between cubic inches and gallons, or cubic meters and liters and things like that. So you can do that kind of thing. But there are some special measures when it comes to talking about how much will something hold. There are some special measurements, but that's really not what we're interested in. What I want to get to is the simple idea of how we get to volume. And essentially what I want you to do is, regardless of the shape, I want you to see what's in common here. Is essentially you have a single face that you can kind of say, okay, I'm going to look at this face, and then the rest is just extended on past beyond. Here we have a rectangle, and then that shape is extended in its same size back in a third dimension. Here we have a triangle, which is the flat surface. That triangle is extended on beyond. And here you have a circle, and then that circle is extended in shape on a certain distance. This remind me of the Play-Doh toy, where you would smush the Play-Doh through a particular shape and it would create this extrusion of either a long cube or triangle or cylinder. And so that's what we're doing. We're trying to find out just how much Play-Doh we extruded out of that contraption. So in the case of the cube, all the dimensions are the same. And so what we would do is we would simply find the area of one side and multiply it by the third dimension. And so the area of one side is s squared, and then we take that times another s. We get the volume is s cubed. So essentially you can think of it as length times width times height. You're taking the three separate dimensions, right? This dimension extends this way, this one extends this way, and this one extends this way, and we're taking those three different dimensions and multiplying them by each other in order to get the volume. And that same idea, that same concept is applied to each one of these shapes. So in the case of the rectangular prism, we're going to first take a look at the rectangle on the end, and usually this again is considered a width and a length, and often this third dimension we just call a height. Okay, so the rectangular prism, once we calculate the area of the end, we simply multiply it by the distance that we're stretching it out in the third dimension, and we'll get the volume. So the volume here is just simply length times width times height. And again, we're going to apply the exact same concept to the triangular prism. We're going to need to know the height of this prism and the base, and then we're going to call this length because we've already used h for this height inside the triangle. So we find the area of the end of this shape, which is a triangle, and the area is simply 1/2 the base times the height. And then we're going to take that square area and multiply it by this third dimension L, and we'll have the volume in cubic units of the triangular prism. Okay, finally we get to the cylinder. We're going to do the exact same thing again. We're going to calculate the area. I'm going to calculate the area of the end and multiply it by the height or length of that cylinder. So how do you find the area of a circle? Well, the area of a circle is pi r squared, so the volume is going to be pi r squared times this third dimension. So here our volume, pi r squared times that next dimension. And these are pretty common shapes, and if you can remember the surface area formulas and how to get those, then finding the volume is simply a matter of multiplying it by that common length or height in that third dimension.